In this section on humans, there are two general areas of study. The first is health and safety. And there's a certain amount of interrelatedness between health and safety and all the other areas of science. For example, when we study electricity, we also realize the dangers of high voltages. As we observe how much life can be in one drop of water, we also become more aware of the existence of germs. As we learn about simple machines in our study of mechanics, we also learn about their power and the importance of handling them properly. And as we investigate our five senses, we begin to realize how vulnerable we are to injury. In this section on health and safety, you might also cover the needs of a healthy body. Fresh air, water, food, rest, and exercise. You should also look into what causes people to get sick and what shots do to help us. Discuss different types of injuries, from scrapes to broken bones, and the roles of doctors and nurses. You can draw an analogy between a human and a car. We use food to operate, and the car uses fuel. We have skin that protects our body, and the car has paint. But unlike the car, when something breaks, we may not be able to replace it. This brings us to the second general area of study, and that's investigating our bodies. If you refer to the physical science tape under the section on matter, you'll see an extensive discussion on our five senses. We cover everything from learning the Braille alphabet and appreciating our sense of vision, to how to properly smell an unknown chemical. These topics were placed in the chemistry section because a primary concept in chemistry is to properly identify an unknown by determining its characteristics. Let's now go on and look at some more activities that you can use to help your students learn more about themselves. In the geology section, we classify rocks according to characteristics of individual rocks. In this section, we could very easily classify humans according to their characteristics. Students should be aware that there's a great diversity and variety in our human race. There's all different colors of hair and eyes and skin. As we continue to learn more about these characteristics, you might suggest that fingerprints are a particular characteristic that can identify one person from everyone else and get them involved in a fingerprint activity. Now, many teachers have had a bad experience with an ink pad in the past and shy away from this type of activity, but fear no more. Here's the way to do it. With a pencil, you build up a layer of graphite on a piece of paper. Then you take the finger that you want to make a print of and rub it in the graphite. The next step is to check it out and make sure that the tip is completely covered, and then get a piece of Scotch tape and carefully lay it over the finger, pressing down evenly so that you pick up all the little pieces of graphite. Then by peeling the tape off, you've now collected a fingerprint. Now, if you want to look at this under a microprojector, you can lay this piece of tape over a slide and then put it under the microprojector, but you're going to see the image is really huge because of all that magnification. Another plan is to let each student build their own little chart of fingerprints by using a worksheet similar to this. Students will have to determine which hand it came from and also which finger. Since this one came from my left hand and my index finger, this fingerprint will go right here. Students can then evaluate their prints and classify each into one of three types. The first is called the loop. Here the ridges enter from one side, form a loop in the center, and exit from the same side. In the arch pattern, the ridges go across the finger with a rise in the center. The third type is called the whorl pattern. Here the ridges circle around a point. There's a good technique for illustrating these three types of prints. First, get an old color slide and punch out the picture, and then tape your print over it. When you put it in your slide projector, you can get a huge fingerprint on your movie screen. Ask your students why we have fingerprints in the first place, why we have these tiny ridges. Ask them what it would be like to pick up a dime if we didn't have the ridges, and relate fingerprints to the soles of shoes with all the little patterns on them. In fact, we even have footprints or ridges on the bottom of our feet. Make sure that they have the opportunity to look at their fingerprints and even the palm of their hand with the magnifiers. Have them also look at the knuckles with their magnifier, and they'll see that when their hand's straight out, there's a lot of wrinkles of skin in the knuckles. Have them close their hand into a fist while they're looking, and they'll see all the little wrinkles disappear. You might even ask them to pinch the skin in the knuckle when the hand's straight out, and then try and pinch it when the fist is closed. They'll realize that we have extra skin there for a reason. Follow up this activity with an investigation of the pores. Take a piece of burnt cork and rub it on your finger, and then wipe off the excess with a piece of cloth. Then you take a look at your fingerprint once again, but this time with a magnifier, and you'll see hundreds of tiny little holes along the ridge of the fingerprint. They look like little pinholes. These are the pores through which we perspire. The body loses about 2 to 10 glasses of water per day, and there's two main reasons for perspiring. One is to get rid of waste products, and the other is to cool the body down when it gets too hot. It's in the process of evaporation that the body cools down. The skin also has a large number of oil glands, and they're associated with individual hairs. We can feel the effect of these glands by running our fingers through our hair. The body secretes oil to keep the skin from cracking and peeling. You can show the effect of washing with soap on this oil with the following demonstration. We'll take 2 test tubes and fill them 1/4 full of water. Then we'll add cooking oil to each to bring them up to the halfway mark. The first test tube will have a little bit of soap in it, and the second one won't. And what we're trying to find out is, how does the effect of soap cut the grease when we're washing ourselves? Well, here's what we'll do. We'll put our thumbs over each and shake them both vigorously. Make sure that the students get an opportunity to look at the results. Let's let it settle for a while and see if the water and the oil are now mixed as a result of the soap. Here's what the results look like 2 minutes later, and this should certainly encourage students to wash with soap. Remember that the skin is really dead, the outer layer is, and it's constantly flaking off, and new skin is coming up to take its place. We can also demonstrate the importance of skin with this little demonstration. Here I've got 2 potatoes. One has been peeled and one has not. Let's let them sit in the classroom for a day or two. The one with the skin will still be protected, and the one that's lost its skin will start to turn brown and decay. You can do the same activity with an apple. As you continue to study the human body, you can always involve your students in an activity where you're measuring reaction time. There's a lot of other cross-content areas covered in this too. First, get some squares and put numbers on them from 1 to 12. Put them all in a hat, upside down, and have students pull out one number at a time. We're talking about a little bit about probability here. On the first draw, you might ask them what number they think is going to come out. You should be able to get any number from 1 to 12. They'll write that first number in the upper left-hand square of this chart. Go on and pull another number out. Write that number here, and continue to pull all the numbers out till you pull all 12 out. Each time, ask the students what they think the next number is going to be. Pretty soon we'll start to see that more students are guessing what that number is, particularly by the time you get to the last number. This is kind of a little mini activity in understanding what probability is all about. Once we've got the chart made up, and this is what my random chart came out to be, we'll have the students break up in groups of 2. Set the chart down on a table. One student's the timer, looks at the clock and says, "Go." The other student starts with their left hand first and hits every number in order. And as soon as they get to number 12, they say stop, and the other person says click, that's the time for that one, writes down the time. So they have to have a score sheet. This one here is a typical score sheet. Here we have 5 trials, so each person gets to try it 5 times with the left hand, record the time, and then 5 times with the right hand. When I tried this experiment, I found some interesting results, and there's a lot of things you can talk about. Let's take a look at what I got. First, with my left hand, I scored around 6 seconds. The high score was 7 and the low was 5. It appears that I may get lower scores if I could get more trials. When I take a look at the right hand after I did the left hand, I found that I did much better. Almost all my scores were 5 and one was 4. Now we could ask our students some basic questions about these results. First, do their scores improve with the number of trials? Second, does the second hand they try have better scores than the first hand? You might even find a correlation between whether they're right-handed or left-handed, and if that has any relationship to how well they score. I happen to be right-handed, and it appears that my right hand did better than my left. But of course, I tried my right hand after I tried my left hand, so I was kind of familiar where the numbers were on the sheet. Maybe it would be better to mix the numbers up again, pull them out of a hat again, and then try my right hand first and then my left hand to learn a little bit about what is really happening in this experiment. And if you want to get more into mathematics, you can start talking about high values, low values, and averages. Now let's continue and look at another fun activity, and this one is measuring your lung capacity. Here we're going to be using a 1-gallon milk container. And the first thing you do is put numbers on it with a marking pen. The distance between each number is about 2 centimeters. The first step is to fill it to the very top with water, and then put your hand, the palm of your hand over it, flip it upside down, and carefully lower it into your fish tank. As soon as you get the mouth of the bottle underwater, it's okay to take your hand away. Look for air bubbles in the top, and if they aren't too big, it's probably okay. Then you need a student volunteer and a rubber hose. Make sure that the diameter of the hose is large enough for someone to blow through. Carefully insert one end of the hose into the mouth of the bottle, and then have the student blow their breath into this end. Now remember, if you're using a bowl instead of a fish tank, when you blow the air in, it'll push the water out and it may overflow the bowl. So you have to be careful on that. When they blow their breath in, they should take one deep breath and see how far down or what number they can fill it to. Once you've blown some air in, let's see, it would go in like this. Once that's done, you can remove it, put your hand back over it again, and bring it out and line up the number and see what value that student scored. Then you're ready to flip it back over again, fill it to the very top, but make sure you take water from the fish tank when you do that, otherwise you'll continue to build up more water in here. And also make sure that you sterilize the hose. A good way to do that is to dip the end in rubbing alcohol. This gets the inside and the outside sterilized, and then you can rinse it off under running water. Allow all the students in your class to participate in this experiment and put the data on the blackboard. See who has a greater lung capacity, the boys or the girls. You might even solicit some volunteers from the upper grades. Make it an intra-school experiment. Here students in your class will see that as they grow older, their lung capacity gets greater. This is also good for interaction between the grades, because when they're in the 4th or 5th grade, they may be solicited to come down to your 2nd grade class and do the same experiment. To continue our study of the human body, we'll investigate how bones are connected together and how the muscles work. First, have the students in your class open and close their hand as many times as they can in a 1-minute time period. Put the data on the board. Their hands should be quite fatigued by the time that minute's up. They'll not only appreciate the importance of exercising muscles, but also the fact that muscles fatigue when they're overworked. You can also talk next about the heart being a giant muscle, and it's constantly beating or maybe opening and closing like our hand does. Let's say your students are 8 years old. Ask them to guess how many times the heart has beaten since they've been born. Put the numbers on the board, and then show them one of the important reasons for learning how to multiply numbers, how to do mathematics to solve this problem. Here's how we'll do it. First, assume that the heart beats 60 times per minute. Multiply that number times 60 to see how many times it beats in 1 hour. That's 3,600. Since there are 24 hours in a day, we multiply that number times 24 to get 86,400. That's the number of beats per day. Since there are 365 days in a year, we find out that it beats 31,536,000 times in a year. Let's take our 8-year-old again and multiply this number times 8 and see how many times it beats in 8 years. This can actually be a measurement of age, as your students go home and tell their parents that they're 252 million heartbeats old. You can also relate the heart to a bicycle pump. The bicycle pumps air, takes it in on one end, pushes it out at the other, and the heart circulates blood. There are 3 types of muscles. The first type we already looked at, where the hand opens and closes. The heart is the second type, and the stomach is a third type, a muscle that grinds food. Let's go back to that first type and make a model. We'll start with a piece of cardboard. Bend it down at one end. Make 2 of these and tape them together. You'll have something that looks like this. Punch a small hole up near the top, and then take this piece and tape it onto a cardboard base. Next, you need a long rubber band to run through the little hole at the top. So get 2 rubber bands and tie them together. Once you've run the rubber bands through the top, run them down through the bottom and connect them at the bottom with paper clips. Our model is now complete, and it could represent our arm from the hand to the elbow. Here are 2 muscles that control the movements of the arm. When the brain tells this muscle to get shorter, what happens to the arm? Well, we pull on the paper clip and it moves the arm. What happens when the brain tells the other muscle to get shorter? It pulls the arm off in the other direction. Students can relate to this because it's a visual model. Then they can feel the muscles actually contracting when they close their arm up. They can feel this muscle getting smaller and bunching up. And if they put their hand under here, they may feel the lower muscle contracting when they straighten their arm out. Once you're through investigating muscles, you can go on and look at the connection point between 2 bones. It's called the joints. There's many different types. We'll take a look at 2. First, bring in a door hinge and show it to your class. Have them notice that the hinge will only fold back so far in one direction, but in the other direction it goes all the way over. Ask them which bones in their body might have a joint similar to a door hinge. The elbow, of course, is a good example. Another good joint to investigate is what's called the ball and socket joint. Here you get an old broom handle, slice a tennis ball, slide it over one end, and then get a larger ball that it'll fit inside. Students can see in this model that the joint connection gives it a complete rotational axis. What joint might we have in our body that would be demonstrated by this? Well, there's 2 that I can think of. One is in the shoulder where our arm can go in a complete circle, and the other is where the upper leg bone connects to the pelvis, where we can swing our leg around in many different directions and even sometimes do the splits. This is the most ridiculous thing I've ever done in this whole tape, but I'm doing it for a reason, all in the interest of science. It's to explain to you, and something that you would explain to your students, on the importance of this shoulder joint up here. Now, don't tie yourself up like this. Get a student volunteer. If the arms are restricted, where we have a short rope from here to the belt and the same over here, and then a short rope connecting the 2 upper arms together, you find you have very little movement with these upper arms. Once you get your student all tied up, have them try and do some things like comb their hair or throw a ball, something like that. Lift an object over their head, try and reach behind their back. Let the whole class participate in this. It's lots of fun. Another adaptation, very important, is our thumbs. How important are our thumbs? How many everyday tasks do you think we could do with our thumbs taped down like this? Have your students work in groups of 2. One student gets their thumbs taped and the other one records results. Each one should try different tasks. Some are quite difficult, like try using a pair of scissors. It's not real easy when you don't have a thumb to use. Or try writing your name with a pencil. I think I've kind of picked that up by now. One of the hardest ones is opening up a wrapped candy, and I'm not even going to try that. These little orange things are the hardest. Even picking up a glass of water can be difficult without a thumb. Students can appreciate the importance of it by doing this activity. There's lots of other adaptations that we don't really appreciate until we've lost them. Think of your teeth, for example. The front teeth are used for biting, and the back teeth are used for grinding, and you can run your tongue along the top of your teeth and actually feel the difference in the sharpness of the teeth, something you might show to your students. And have them try and drink some water through a straw without using their lips sometime by just holding the straw between their teeth. It's impossible. Well, I'm going to have to go on now and get into this next section on ecosystems, so I'm going to have to do some type of Houdini trick to break out of this.